All right, should be live and Facebook and YouTube. Running a tad, a few seconds behind. Let me get. Hey, my name is. Hang on a second. Back off that a little bit. Name is Grant Swaim. I'm the head Kahuna here. Let me get my. I was on a podcast learning something. Now I got to jump in here. We're going to do tonight was going to be on voltage. Let me share my screen here. Let me get that up. Get that up. Share screen. Add that to stream. So let me grab tonight. We're going to do a 20-minute talk about voltage. That was the plan for tonight. And I got each night I'm trying something new. Tonight is Let's Talk Voltage. I think tomorrow night's Let's Talk Current, and the next night Let's Talk Resistance. That's the three pillars. And we start with DC. We start with DC electricity, voltage, current, resistance, the three factors that are related mathematically to each other. And so we're going to look at, I'll bring my screen up. I'm teaching off of my site, Gearhead School, and it's 70 lessons. We'll be looking at the voltage lesson tonight here again, and two more lessons over the next consecutive nights. The one last thing here. I like that. Let's do this. So let me, we'll go through and start, if you're watching on Facebook or YouTube, just throw a comment in. I can see the comments right on the screen, and then I can bring it in and actually always ask questions. Use the comments to ask a question or to tell me something I need to do differently. But then I'll actually take your questions live and try, as long as it relates to the course. You know, right tonight it's on DC voltage. So let me pull the screen up, and I'll sit over in the corner. I don't think I have much to the equation here, but so under electrical essentials, you see there's I think 10 lessons, and tonight we're going to focus on voltage. And so let me just go ahead and call the voice of God in the business. You'll hear me talk, but you won't see me because I don't think my face adds much to the equation, and I can pop back in if I need to. So we go full screen, and so this is lesson 60 called Voltage Essentials, one of, like I say, I think it's 80 lessons. The way I like to do things, I was a educator at the community college system for 15 years, and kind of know my way around the block on teaching, but I like to be very specific and granular. I don't like to talk about soup to nuts or A to Z in one conversation. So then you'll see if you look at my course, there's very finite lessons that cover one thing, and so you don't have to read the book from front to back of one to find something. You can go in and take. I support the concept of just-in-time learning. So every lesson starts off with a video, which is an overview of the lesson itself. Then when you scroll down, when you hit this lesson, which is voltage, you'll see jump links right down to points within the lesson. And so I'm real big on you don't need to, read the lesson from top to bottom to find one little piece of information. If you want to learn about how to measure source voltage, you'll see a link that will take you straight to that point. So you can drill down very fast and find one piece of information. A lot of times you use the water analogy with voltage, with DC electricity. So think of voltage as pressure. Voltage does not flow through a wire. What goes through the wire is current. But voltage is sometimes you'll read some books that says EMF, electromagnetic force. And so, like I say, We can use the water as a great analogy. And so voltage is pressure. The unit of measure is a volt. That's simple enough. And if we go lower than 1 volt, we usually go to millivolts, and milli means 1,000. So it just sounds, you can charge more money if you say something like it's got a 500 millivolt drop, which is a half a volt. So typically you go under a volt to go to millivolts. And if you go into large numbers, which you won't find on the primary system, the secondary is going to be the ignition system that fires off the air-fuel mixture. That gets into kV, that's kilo for 1,000. I've got a little age on me back in the day. 15, 20,000 volts was the ignition system. Now we're approaching 40 and 50,000. I mean, some big numbers because we run leaner and leaner, and the leaner mixture is harder to fire, and then we have higher combustion pressures and turbocharged and the wider gaps on the spark plugs. So you get to be some really high numbers on voltage. So kilovolts is pretty much the ignition system. A term used in voltage, source voltage, is talking about the battery if the car is cut off, or the alternator or your charging system if the car is running. Source voltage is the source of the voltage that is powering the car on the low voltage side. This is not about the ignition system voltage we discussed earlier. That's called high tension or high volts. So source is going to be the battery if the car is cut off. You hope if the car is running, the alternator is going to produce voltage higher than the battery, and all the current would come out of the alternator. If you have an alternator undersized or underperforming, and you got a lot of stuff turned on, you've added, a bunch of electrical equipment, you could outrun the capacity of the charging system, then be pulling from the charging system and the battery. That's not a good thing. You don't want to run the charging system at 100% capacity. It's not going to last very long. Some more terminology. Open circuit voltage test is a fancy word for it, meaning that you're going to check the voltage with nothing turned on. You walk up to the car, you pop the hood open, everything's turned off, and you check right across the positive and negative post of the battery. And that can give us some information. If the car hasn't ran in maybe 30 minutes, or because if you run a car in the charging system, we'll put a surface charge on a battery, but let the car sit for a few minutes, turn the headlights on for a couple of minutes, let it sit a few more minutes. The voltage on the battery is a very, very accurate indication of state of charge. You really don't need to have all the little bubbles or the things that float, and what you're doing there, you're checking for specific gravity. Open circuit voltage test means you look right across the positive and negative post, make sure it hasn't been running in the last 15, 20 minutes, or put a little bit of a headlights on for a minute or two to knock off any kind of surface charge, and that number is very accurate. And this is a chart here that shows the state of charge of the battery. And if you elect to enroll my course, you'll get copious amounts of videos. This is one I personally made. Have access to a very large Honda shop, and got keys to the place. It used to be mine. Not that shop, it was an earlier shop, but so I do try to make a fair amount of my own videos. And when we talk about here again voltage, the alternator is a source of DC voltage. When the car is running, it's going to power the entire car plus recharge the battery. That cable, and I say cable because it's a large wire that comes off the positive post, output post of the alternator, goes directly to the battery positive post. There may or may not be a kind of master fuse in there. So you always want to make sure you disconnect the battery before you go change an alternator out, because on the bottom of the car, you take this output post off, you take this cable loose, and it gets away from you, and it's still hooked on the battery at the other end. It can be pretty spectacular. So that wire off the output post alternator goes straight to the battery positive post. Now, let's start talking about, now we're looking at schematics, and we're going to talk about measuring voltage. Remember, this entire lesson is on voltage. I have another lesson tomorrow night on current. another lesson the next night on resistance. Voltage is measured by a voltmeter, and we're really just skimming this information. There's in this course is lessons on meters and how they're used. But this is called a parallel relationship. I'm going to touch the circuit in two places. I do not open the circuit up. I take and touch the circuit in two places. That's how you measure voltage, the difference of potential between 2 points. And so the illustration wouldn't let me hook the wires right to the positive and negative post, but that's really what we mean here is you take a voltmeter, hook straight across the positive and negative post on the battery, which is the main source of power. And that's how it's called source voltage, because that's the voltage, that's the source of the voltage to run the car on. That's the fundamental, kind of the first voltage check you probably will do and use on a normal basis. Car comes in, you will see, is it charging now? Is the battery charged, steady charge? All will go back to source voltage. And remember, if you got a question, according to my software, I'm kind of new at this. I shouldn't say that, but I'm looking at a couple of people watching. Put a comment. I try to make sure, keep my eye over here. Keep a comment. If you make a comment with either platform, it should pop up in my panel, and I can actually put the comment right on the screen and then try to address that directly. And then a video that I made here again in this on how to measure source voltage. And then when you start talking about the fuse box, and it's also a good time to sneak in a conversation about power distribution. When the positive post, the cable comes to the positive post, when it leaves the positive post of the battery on the way to the fuse box, is not protected. It's not protected. So you should, if engineers got any sense at all, the fuse box be very close. And that's why I made a video and showed this. This fuse box is literally within inches of the battery. So the cable from the positive post of the battery to the fuse box, a big heavy cable, is not protected against a high current. So if that something wears through that wire and it gets to ground, hopefully it'll burn the cable in two before it gets so hot the battery could explode or melt down. But if you're going to build your own custom dune buggy, or you're going to build something, you're going to build a car, make sure that the battery it feeds a fuse box very close by. Don't let the positive post or the positive cable run long distances in the car before it gets to the fuse box. It's not going to work out well if that cable gets to ground. And you can do here, you'll see in some other lessons that I have, which here again are available in the course. A tremendous amount of diagnostics can be done right there at the fuse box. So I can pull these fuses out and push in fuse loops and put a current clamp and stand there at the fuse box and look at the current feeding the fuel pump, injectors. I can tell the RPMs, the fuel pump, and the injector panel movement. Really high-end topics, but I can get a lot of diagnostic information from looking at the current flowing through the fuse box using like a current clamp, where I'm looking at and scoping this and looking at the panel or current change down to the milliseconds. It's a game changer when it's come out 10 or 15 years ago. The kissing cousin to voltage is voltage drop. And remember, source voltage is this pressure, and it causes the current to flow through the wire and power a circuit and the loads. But when current flows through resistance, just like when river or water flows through resistance in a pipe, across that resistance, which is actually a load, a motor. I mean, it's every circuit's going to have a load that does something. A motor that spins and causes the wind to go up and down, or light, all types of electromagnetic equipment on the car, and anything like that. That's called a load. And if you have one load on a circuit, all the battery source voltage should show up at the load. Anything that you lose getting there on the power side or getting back on the ground side is going to be robbed from the load itself, and it's not going to perform as planned. Now this is showing a voltage drop, so you can take the same voltmeter that you check source voltage and go out on the circuit and check for voltage drop. The circuit has to be live, so you can turn the circuit on. In this case, we're looking at a motor. Let's say we want to check a blower motor, and it's not performing quite right. It sounds slow. It's not moving much air. And the blower motor's tucked in by the dash. You don't have to go physically rip into the dash unless you know for certain the problem is with a blower motor. And you may be dropping the current through a fuse holder that's rusted or a bad connection. So we could actually take a voltmeter, go right across, in this case, a fuse holder, fire up the motor, and see if there's any significant voltage drop across a fuse, which should be close to zero. So if I'm measuring 2 volts, this dropping across this resistor, that 2 volts is robbed from the motor. So if I had a 12-volt system, I'm dropping 2 across the fuse holder. I only got 10 volts left at the motor, and guess what? The motor's going to run slow, and that's a problem. So you can use voltage drop. It is absolutely the way to find unwanted resistance. An ohmmeter is, well, close to useless to do this. It's just, you're not going to fix. People always ask me, what would you get rid of? What would you get rid of if you had to get rid of something? I just don't fix cars with an ohmmeter, and I'm sure somebody's going to disagree with that. But you'll find specs on some component, and it'll have a resistance spec, and you'll measure it in specs, but things still don't work. And if you want to find resistance where it's not supposed to be, do the voltage drop principle. It's a good test to run. So that concludes here again, all my lessons are very granular. They cover one topic. You get this knocked out, and then you can get right on to current, resistance. Actually having one on voltage drop itself. It gets more deeper into voltage drop. As a matter of fact, before I sign off, I'll scroll up and you'll see there's accordions. So in between with electrical essentials, we talk about the overview and atomic level, voltage, one on current, one on resistance. Electrical circuits, big on terminology, start looking at what a circuit looks like. The circuit faults, what goes wrong with circuits. Sometimes it's voltage drops, sometimes it's open, sometimes it's shorts. And voltage drops are there's a whole section I do, a lesson on voltage drops. One of the best ways you can diagnose and find resistance in a car, signal acquisition. How do we get all these signals? How do we find out what the current is in a given wire? How do we get a good accurate voltage reading somewhere in the circuit? We don't want to take out our pocket knife and cut a hunk of insulation off. There's all kind of ways to acquire signals. Multimeter use. What are some of the best models to use? What are how do I use a multimeter and measure voltage, resistance, and current, and a couple of other tricks up their sleeves? How's the best way to use a multimeter? And then we get into control devices like switches and relays. This is on switches, that's on relays, and then I think I finish up with circuit protection. We talk different types of cylindrical fuses, bladed fuses, fusible links, circuit breakers. So as you see my style, I break everything down to very digestible chunks of information. And when you take a course with me, I'm also do a lot of live streams. I do at least one live stream a week, which is open to everybody. It's in the course, and I have other live streams I do for other clients or groups that want a little more than the standard live stream. So thanks for coming in. Matter of fact, this will be a good time. Did I tell you I'm new at this? Shouldn't, but so this is in my home. I have a dedicated, I call it a studio. I'm pretty proud of it, quite frankly. It's. I don't have other cameras set up right now. I should have done that earlier, and I could have give you the shot of I'm sitting at, a nice setup, so it's very easy. I can get through here, shut down, and walk down the hall and rejoin my wife, and so this is easy for me to produce and get it out. I try to do a good job. I want to help anybody, the individuals through, I have Essentials course. We have a curated YouTube database, and also do work with in the shops for corporate accounts where they can buy a set of seats and swap their techs out, their newcomers. This is all focused on essentials. I don't think anybody does essentials any better, and that's where if you don't have a solid foundation of essentials, you're going to not have a strong foundation to move forward on. So let me go ahead and wrap up. Thanks for watching. Probably we're getting to have doing 2 or 3 live streams, 8 o'clock Eastern a week. Like I say, it's easy for me to logistically pull this off, and I enjoy trying to teach people about the automotive service industry. See you on the next live stream.